Solid angle. Objective: to introduce solid angle as a three-dimensional analog to the plane angle. Let us first construct a plane angle. Consider a curve and a point O on the plane. Let A and B be the peripheral points of the curve. Let us draw two lines L1 and L2 starting from O, which pass through A and B respectively. Consider an arc of radius r, taking O as the center, that is enclosed between the lines. The plane angle between the lines, theta, is defined as the length of the arc, L, divided by radius of the arc, r. We can extend this construction technique to define a solid angle in three-dimensional space. Consider a surface and point O in three-dimensional space. Draw lines from O which pass through the peripheral points of the surface. This gives us an irregular cone which perfectly encapsulates the surface. Consider a spherical surface of radius r centered around O. Let the surface area of the spherical surface contained in the cone be S. Solid angle omega is defined as the surface area S divided by r square. Solid angle is measured in steradians, whereas plane angle is measured in radians. This is akin to, as in the case of plane angle, ratio of arc length to radius. If a complete sphere is considered, surface area S becomes 4 pi r square. Omega is equal to 4 pi. Thus, the solid angle made by any closed surface at an internal point is equal to 4 pi. For example, let us find the solid angle omega made by one of the faces of a cube at its center. From symmetry, it can be inferred that each face makes an equal solid angle at the center. Total solid angles made by all faces, 6 omega, must be equal to 4 pi. Hence, solid angle made by a face at the center is equal to 2 pi by 3. Let us look at a problem on solid angle. If every point on the periphery of a spherical cap makes a planar angle theta at the center of the sphere, what is the solid angle omega made by the spherical cap at its center? Consider a circle, all points on which make an angle alpha at the center. Similarly, consider another circle with angle alpha plus d alpha. The thickness of the ring formed between the circles is r d alpha. Radius of the ring is r sin alpha. Hence, area of the ring dA is product of circumference 2 pi r sin alpha and thickness r d alpha, which is equal to 2 pi r square sin alpha d alpha. To get the area of the spherical cap, we shall integrate dA from alpha is equal to 0 to alpha is equal to theta, taking the constant term out of the integral. On integrating and substituting the limits, we get S is equal to 2 pi r square 1 minus cos theta. Solid angle omega made by the cap at the center is S by r square, which is 2 pi 1 minus cos theta.